So one of the problems that many teachers love putting on a test, I'm not particularly one of them, but they just put this first problem here for A. Again, we're finding integrations or integrals or antiderivatives. Here you're saying, what do you take the derivative of to get dx? Well, really that makes no sense to me. So what you really want to think about is what do you take the derivative of to get the answer 1? When you just see a dx there, really there's inherently the number 1 times dx, right? So what do you take the derivative of to get 1? Well, remember the antiderivative of a constant is that number times x. And then, of course, you have the plus c, but 1 times x is just x. So what are we saying? We're saying if you take the derivative with respect to x of x, you just get 1, which is exactly what the original problem was. Okay, so be really careful with that. And then remember, you must remember, or don't forget, plus c. Okay? Don't forget plus c. So in fact, to ensure that I don't forget plus c, I'm looking at every single one of these questions on this page. Immediately what I'm going to do is write plus c on every single one of them, because I know every single one of them has an arbitrary constant. So just get it out of the way, put the plus c's, don't forget the plus c's. So my answer was x and then plus c. There's my answer to the problem. Okay, let's look at the next one. How do I find the indefinite integral of x plus 2? Well, what would you do? You would just separate it. Find the indefinite integral of x with respect to x plus the indefinite integral of 2 with respect to x. So what's the integral of x? Well, that's x to the first power, so we can use the power rule, which would be x to the power plus 1, which would be the second power, divided by that exact same number, plus what's the integral of a constant? The integral of a constant, just like the previous problem, is the constant times x. Remember, we always have to remember the plus c in our final answer, but I'll put that over in the other answer. So my guess is the answer is x squared over 2 plus 2x. Are we right? I don't know. Let's find out. Let's find the derivative. So what's the derivative of x squared over 2 plus 2x? Well, the derivative of x squared over 2 would be 2x over 2, plus the derivative of 2x would be 2 times 1. And this would be, well, the 2's would simplify, x plus 2. That is our original problem, so we have found the antiderivative. What do we take the derivative of to get x plus 2? The answer is take the derivative of x squared over 2 plus 2x plus any constant, plus or minus any constant, and you would get x plus 2. Let's look at part C here. It says find the antiderivative of 3x to the fourth minus 5x squared plus x. In other words, what function do I take the derivative of to get this? So what are we going to do? We're going to separate it. This is going to be 3 times the antiderivative of x to the fourth with respect to x, minus 5 times the antiderivative of x squared with respect to x, plus the antiderivative of x with respect to x. Look at each part individually. So this first one would be 3 times, well, the antiderivative of x to the fourth, we have to raise it to the power plus 1, which would be 5, and divide it by the same number. Minus 5 times the integral of x squared. Again, the power plus 1, which would be x cubed, divided by the same number. Plus the integral of x, well, that's x to the first power, so it would be the power plus 1, x squared, divided by the same number 2. Of course, our answer here is going to have a plus c in our final answer, but what I'm getting is 3/5 x to the fifth minus 5/3 x cubed plus 1/2 x squared. You can write them as fractions. You could have kept them essentially how we had it written before, but I like writing them as constant multiples. So again, what have we said? The problem said, what do you take the derivative of to get this? And our guess is the answer is 3/5 x to the fifth minus 5/3 x cubed plus 1/2 x squared, of course, plus c. Are we right? I don't know. Let's find out. How do we find out? Take the derivative of your answer. So what's the derivative of 3/5 x to the fifth minus 5/3 x cubed plus 1/2 x squared? Well, this would be 3/5 times 5x to the fourth minus 5/3 times 3x squared plus 1/2 times 2x. Okay, let's check it out. The 5 simplify, the 3 simplify, the 2 simplify. I'd be left with 3x to the 4th minus 5x squared plus x. Go ahead and look at the original problem. Those match, so we know we have the right answer. So our final answer again would be 3/5 x to the 5th minus 5/3 x cubed. I'm going to erase that plus c that I wrote earlier because it's where I need to write, okay? So then we have the plus 1/2 x squared plus c. That would be our final answer on the problem. Excellent. Okay. So, number 5 lends us to think, okay, is there an antiderivative rule for the quotient rule? And the actual answer is yes, there is something that kind of undoes the quotient rule, but it's way too complicated for us right now, and it is not something we want to think about, okay? We want to get rid of using the product rule and quotient rule, the antiderivative product rule and the antiderivative quotient rule, as much as possible. So if there is any simplification you can do, please by all means do it first. So what am I talking about? Well, I've taught you with derivatives, anytime there's only one thing in the bottom, your best bet is to separate and simplify first. Sorry, let me write this. So what would we have? We would have x over the square root of x plus 1 over the square root of x, and all of that's with respect to x. I'm going to clean that up though. X over the square root of x, so that's x to the first over x to the 1/2. Division, you subtract the powers, so that'd be x to the 1/2 plus 1 over square root of x is x to the negative 1/2. And that's with respect to x. So what do I do now? Well, separate it and find the integral or antiderivative of each individual part of this. How do I find the antiderivative of each part? I use the power rule. So what's the antiderivative of x to the 1/2? Okay, well now I need to do x to the power rule. What's 1/2 plus 1? Well, that would be 3/2. But then again, I need to divide it by that exact same number. Plus, what's the integral of x to the negative 1/2? The integral of x to the negative 1/2 would be x to the, well, negative 1/2 plus 1 would be positive 1/2, but then I need to divide it by that exact same number. And then, of course, I have my plus c in my final answer. Okay, well, remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So instead of dividing by 3/2, that's the same thing as multiplying by 2/3. So this would be 2/3 x to the 3/2 plus 2 over 1, which is just 2, x to the 1/2, and then we would have the plus c. Now, I could technically rewrite this into radical form, but I am not going to. There's no need for me to rewrite this in radical form. Complete waste of time. I'm going to leave it just like this. So what's the idea? It says, what do I take the derivative of to get what's equivalent to x plus 1 over the square root of x? My guess is the answer is 2/3 x to the 3/2 plus 2x to the 1/2. Let's see if we're right. How do we find out if we're right? Let's take the derivative with respect to x of our answer. So we have 2/3 x to the 3/2 plus 2x to the 1/2. Let's take the derivative. Well, that would be 2/3 times 3/2 x to the 3/2 minus 1, which is 1/2, plus 2 times 1/2 x to the 1/2 minus 1, which would be negative 1/2. And when I do that, my 2/3 and my 3/2 simplify, so I end up with x to the 1/2, plus, now my 2 simplify, and I get x to the negative 1/2. Well, remember, that is equivalent mathematically to what we had x plus 1 over the square root of x is, just with a little bit of simplification, right? So it doesn't look like the original problem, but it is mathematically equivalent to the original problem. So that means I do have the right answer. So the right answer again would be 2/3 x to the 3/2 plus 2x to the 1/2. Let me get rid of this plus c again. Plus 2x to the 1/2 plus c. Again, we could technically write that with radicals, but I'm not going to. I'm not going to waste my time. I am okay with you leaving your answers in exponential form, and WebAssign is okay with it as well. Okay, now we get to what I consider are the fun problems. This is where I really check to see to know, do you know your trig identity? So while I think they're fun, you might think they're miserable, because the thing with trigonometry is there's almost an infinite amount of substitutions we can make, and you have to see the perfect substitution to make these problems work. So for instance, on example 6, we have the sine of x over the cosine squared of x. So you might not see this, but I'm seeing it already, because what I'm thinking of is we have one sine on top and two cosines on bottom. And so what I'm really thinking about this is something like this right here. 1 over cosine of x times sine of x over cosine of x. Again, I have one sine of x on top, and I have two cosines of x on bottom. Now, that's just a trick here, because look, think about this. What is 1 over cosine of x? Well, that is secant of x. And what is sine of x over cosine of x? That's tangent of x. So the question is, what do I take the derivative of and get secant tangent? And the answer of that is secant of x, of course, plus c. So if you didn't see separating that, if you didn't know your trigonometric equivalencies, that 1 over cosine of x is secant of x, and that sine of x over cosine of x is tangent of x, you never would have been able to do this problem. So a nice little trick there makes this problem super, super simple, as long as you know your trig identities. Are we right? Well, let's just check real quick. We're saying, what do you take the derivative of to get what's equivalent to sine of x over cosine squared of x? And we said the answer is secant of x. We'll take the derivative of secant of x, and you get secant of x tangent of x. And again, secant of x tangent of x is mathematically equivalent to the original problem through algebra. So while our derivative doesn't look exactly the same, it is mathematically equivalent to the original problem, just like we had on the previous problem. So we do have the correct answer. So what's our answer? The answer is going to be secant of x. Let me write it in black. Secant of x plus c. Really cool problem there.